The normal distribution is common in statistics mostly because it's a very common distribution for real data. For example, this input uses the air temperature data function to get the mean daily temperature at one location during January, February, and March for about 40 years starting in 1980. The result is a list of a few thousand temperatures. And here is a histogram of that data together with a normal distribution with the same mean mu and the same standard deviation sigma as the data, which shows a good match between the data and the normal distribution. The point of this example is that there isn't anything particularly special about this set of temperatures. Here are similar plots of average daily temperatures for 6 other locations at various times of year, all of which show a good match between the data and a normal distribution. The normal distribution in fact comes up for almost any data that originates from a suitably random process. For example, this input uses the financial data function to get the fractional daily change in the Dow Jones Industrial Average for 4 years starting in January of 1990. And this shows a histogram of that data with a comparable normal distribution. The normal distribution is again a good match for the data. The normal distribution is so common that sometimes even a small departure from a normal distribution can be a noteworthy feature of the data. An interesting feature of this data, for example, is that the distribution of this data is consistently above the normal distribution in the tails of the distribution. A distribution like this is called a heavy-tailed distribution. In this example, the tails of the distribution are heavy because large fractional changes in stock prices are more common than would be expected for normally distributed data. The formula for the probability density function of a normal distribution with mean mu and standard deviation sigma is given by this expression. A plot of this function is a curve with a maximum at mu and where the width is controlled by the standard deviation sigma. Most of the probability under the normal distribution curve falls near the middle of the curve. A few specific probabilities that may be worth remembering are that about 68% of the probability falls within one standard deviation of the mean, about 95% of the probability falls within 2 standard deviations of the mean, and about 99.7% of the probability falls within 3 standard deviations of the mean. This set of percentages is called the empirical rule, or sometimes the 68, 95, 99.7% rule. One last bit of terminology to know about is that the normal distribution with mean 0 and standard deviation 1 is called the standard normal distribution. This is the normal distribution that is most often found in tables, and it's also a convenient distribution for calculations. The critical value z star used in computing confidence intervals, for example, is calculated from the standard normal distribution.